Okay, so when you're trying to solve for this, you kind of see this 6x to the business is kind of repeated. So you're like, I wonder what's, what I can use as a variable to represent that. So if it was both 6x plus 1, that would make it easier. So let's see if we made it 6x plus 1, what would that look like? So let's go 6x plus 1 plus 6. Well, I can rewrite this as x plus 1 if I just add a plus 1, right? So that's the same thing. X plus 1 is the same as saying x plus 2. But then I now see both of these terms have the same. They look identical, so I can replace that with the variable. And that's what I'm trying to do, is just trying to find two things that look identical, so I can say, let p equal 6x plus 1, right, or something. But let's see how we rewrite this. So I'm going to take this part up here just to show you what this is. There's this rule, which is, let's say, a to the, I don't know, a to the x plus y is the same as saying a to the x times a to the y, right? That's kind of just an exponent rule. So I'm going to use that here to rewrite this next line. So 6x plus 1 plus 6x plus 1 times 6 to the 1, right? So it's using the same rule, where two things with the same base, when you multiply them, right? You're going to multiply, you add the exponents. So I'm adding this x plus 1 added to this exponent here. So that's this exponent here, and this is this exponent here, right? So that's the same thing. So now you see, and let me just carry this 7. So now you see what we're going to do with this. Now, because both of these expressions have the same guy in it, I could let a variable, let's say, let p equals 6x plus 1. So now what we see is we have, p basically plus p times 6, which another way of writing that is 6p, right, is equal to 7. And so if we solve for that, well, 6p plus 1p, that's 7p equals 7. That means p equals, if you isolate 7, divide both sides by 7, you get p equals 1. Okay, great. So now let's solve for it. P was originally, let's see, p was really 6x plus 1. So that means 6x plus 1 equals 1. Let's solve for this. Well, this is where we use our log rules. What's our log rules? We know, let's say, we can take the logs of both sides. So I'm going to take this log, 6x plus 1 is log of 1. And now our log rules teach us, let's say, log of a to the b is the same as saying, b log of a, right? That's kind of a log rule. You take this guy up here, bring it to the front. I'm going to do that here with this x plus 1. So this will be x plus 1 log of 6 is equal to log, I think I'm saying it wrong. And it's log of 1. So now what I have here is log of 1 is actually 0. So this makes it a lot easier. So basically we have x plus 1 times log of 6 is equal to 0. Now I divide both sides by 6, log of 6. We know what 0 divided by anything is. So that just gives us x plus 1 is equal to 0, because 0 divided by log of 6 is just 0. Let me just solve for x. X equals -1. And we can go back to the top, see if that makes sense. So if I put a -1 in here, if I put -1 plus 1 is 0, 6 to 0 is 1, that works. -1 plus 2 is 1, 6 to 1 is 6, 6 plus 1 is 7. So that checks out. You just want to double check that it works. That means x equals -1 is a solution.